Hello, welcome to Physiological Factors Screencast. Today's focus is going to be on components of fitness, and the first component of fitness we're going to have a look at is muscular strength. So, muscular strength, if you have a look on here, is an majorly on the majority of the time an anaerobic component of fitness. Okay, so it really does fit in well to our sequence of work that we've been looking at. Now, if we have a look onto this, I've kind of just mentioned this that it's anaerobic because this follows our chain of events that we've been looking at with regard to anaerobic fitness. So if we have a look over to here, you can kind of see down to this bit, you can see where we've gone so far. So we've looked at our threshold concept here, as well as movement analysis and motor unit, and then we've gone down to our muscle fibers, fast oxidative glycolytic 2A, glycolytic 2B, ATPPC system, glycolytic system. Now we're into the components of fitness that are used when we're performing high intensity contractions. So we're into muscular strength. So we need to really kind of dig into this now, and then after that we'll have a look at our ergogenic aids that can increase the performance of muscular strength. Okay, so let's have a look on them. This is a specification. These are the things that you will be required to do by the end of muscular strength. Today's screencast is going to focus on the first column. So it's going to have types of strength, factors that affect strength, and methods to evaluate each type of strength or the types of strength that are required. So that's what will be done. At the end of the screencast, you might just want to check, see if you can do this stuff. In the lesson, we'll have a look at how we train to develop these different types of strength. Okay, so if we have a look over here, first topic then, types of strength. So when we're looking at types of strength, we need to know 5 different types of strength. We need to be able to give a kind of a definition of them, and I will give you maybe an example linked to sport, because of course this is looking at us from a sporting point of view, as well as improving our strength. So starting off then, maximum strength. So starting off with our maximum strength, then this refers to the maximum force the neuromuscular system can exert in a single contraction. So you're thinking about things such as shot put, okay, so in athletics, and you're looking at things like it might be a maximum strength, so like a 1 rep max in weight training, okay, but ultimately it's the maximum force the neuromuscular system could exert in a single contraction. If you don't want to put neuro, you feel more confident with muscular, you could just put muscular. Okay, so going on from there, strength type 2, explosive strength. So explosive strength then, again, is a form of maximal force, but it's exerted with a high speed of contraction, okay, in one or a series of movement. So you look in here, so there's another example, this is called elastic strength. So elastic strength links to something called a stretch reflex, and a stretch reflex is looking at the muscles and tendons and its ability to stretch and reflect back up. So for example, you're looking at things like a basketball player here jumping to block in basketball, a high jumper pushing down into the floor with extreme speed and power so they can get over the bar. Okay, so there are 2 examples here. So these at the moment, as you can see, extremely high intensity movements we've got here for a single contraction for maximum strength, and then we're looking at this maximal force with a high speed of contraction in one or a series of movements. Now, the last type of strength that is massively linked to these kind of high intensity movements is something called dynamic strength. And this type of strength basically involves overcoming a resistance with a high speed of contraction. And I put in brackets there power output, because I think in GCSE PE would have used the word power like as a combination of speed and strength. And that is what this is. So for example, a triple jumper, when they're getting into their kind of 3 steps, the hop, the step, the jump, okay, that would be an example of dynamic strength, overcoming the resistance to the floor, okay, with a high speed of contraction and power output. Okay, so that will be that one. Now, what I'm hoping you'll see now is, we've got 5 types of strength. The first 3 that we've looked at there, maximum strength, explosive strength, and dynamic strength, you need to have a go at kind of defining them. I will help you with kind of work on that in lesson. But just at the point now, if I start to get you to think synoptically, I would ask you to start think now. Can you start to think, so what you've covered so far, for example, muscle fibers, when you looked at energy systems, could you start to think now what muscle fiber you think would be most linked to these types of strength that you've used? And that will start to get you thinking kind of laterally about kind of where we've gone on our sequence. So I'll put onto here, obviously with regard to fiber type, we're looking at a fast glycolytic 2B. Okay, for these really explosive actions, high intensity energy. And in terms of the energy system, it would fall under the ATP-PC. Okay, with some of these maybe being allowed ATP being able to use for them, some of them requiring PC to resynthesize ATP. So you can kind of think and see of those two high intensity energy, okay, that we need to produce these types of strength. I'm hoping you can see how that fits in. Now, the next type of strength is strength endurance. So strength endurance refers to the ability to sustain and withstand repeated muscle contractions. For example, you're looking at freestyle in swimming. Okay, so you're looking at like 100-meter freestyle, and that could be really high intensity, but you've got to sustain and withstand the muscle contractions. Now, when you're talking about this type of strength endurance is not just doing it for a high intensity movement for a short period of time. This one's looking at sustaining and withstanding repeated high intensity contractions, and I think swimming's a great example for that. So if we look at that and think now, I get you to think now, this one would be slightly different in terms of energy system and muscle fiber output. So if we have a look at this, synoptically linked to fiber types that would be linked for this, fast oxidative glycolytic 2A, and the energy system will be more towards the glycolytic system. Now, I've put these green things, the synoptic links in green. Do you have to write them? I think it's just useful to do it. Because you could get little short questions linked to these, but it's not absolutely mandatory. I just think it's good for you to start thinking about fiber types and energy systems with regard to your types of strength, because it allows that sequence and that increased interleaving between concepts. So if we go on from there, the final type of strength is something called static strength, and the static strength it basically refers to the ability of muscles to overcome a resistance but staying the same length. Now, at this point, I would say to you now, do you remember the type of contraction we had a look at earlier in the year that involved muscle staying the same length? Okay, so you should be able to remember that. Remember isometric. Okay, so isometric was a type of muscle contraction where muscles stayed the same length. It can also, static strength can also be, in some literature, be referred to as isometric strength. Okay, this specification requires you to know it's static strength. For example, gymnasts use this all the time, holding a handstand position, the crucifix position in gymnastics. These are examples of sporting situations where this might be used. Okay, if we move on from there then. A massively important part of strength is being able to evaluate it. So if you need to know, certain sports will need certain types of strength, as I've just shown you back there. So it's important that physiologists or sports scientists can actually provide tests and measure your levels of strength in the different areas. So if we start off, maximal strength, okay, now there's two measures for maximal strength, but the one that it seems will be used the most, and massively used the most, you might have used it yourself, is something called the 1 repetition maximum test, or the 1 rep max test. Okay, and basically it involves here the subject picking an exercise. It could be a machine weight, it could be a free weight. I've just used the example of a bench press here, and what the performer will do is they will pick a weight, a relatively heavy weight, okay, and they will go at that weight and they will try to lift it for 1 repetition. They will keep increasing their weight until they can only lift 1 repetition at a time, and that gives them their 1 repetition max. Okay, this test is absolutely vital, because the amount of weight you can lift for 1 rep, what afterwards you'll look at in the lesson, is that in order for somebody to improve a different type of strength, no matter what type of strength it is, any of the 5 we just looked at previously, there will be a percentage of the 1 repetition max required in order to improve different types of strength. For example, if you wanted to improve strength endurance, you would do your 1 rep max test, and then you'd have to try and work at somewhere between 25% and 75% of that 1 repetition max to improve your strength endurance. So 1 repetition max then, I've got off pieced a little bit there. So if we go with that, 1 repetition max, you've got to be able to give a quick description of it. Okay, once you've done that, you then have to be able to give an advantage and a disadvantage. And a good advantage of this is it's a direct measure of strength. However, due to the maximal nature of it, it has the risk of leading to injury. Now, 1 repetition max test is not the only test for max strength. Okay, we also have something called the grip strength dynamometer, and basically this is a kind of a grip dynamometer that you have, and you grip hold of it. First of all, you put it straight above your head, straight arm, and what you do is you bring your arm down while squeezing the grip dynamometer as hard as you can, and you do that 3 times on each arm. Now, you would have probably done this at GCSE, I imagine, within fitness there. So That's what it is. So you grip it with your hand, and the advantage of it is it's simple to perform. However, it only measures forearm strength, so it doesn't really give us a kind of wide-ranging understanding of strength. Okay, so next type of strength, explosive strength. So explosive strength then, basically as we looked at before, it's kind of that high intensity, kind of speed, maximal strength, but done with a high speed. The key strength test for this is called the vertical jump test, and it basically involves the subject jumping. You usually have next to a wall. You'll have a kind of on the wall. You'll have like a kind of the broad jump kind of or the kind of strength thing there, where you jump up and you have to reach with one arm against the jump board and seeing how high you can jump to touch, and that gives you an idea of your explosive and elastic strength. Advantage, very simple to perform, but the downside is it only measures leg strength, because that is the kind of muscle that's contraction. Strength endurance then. Strength endurance, as we looked at, ability to withstand and repeat muscle contractions. How do we test it then? So you might have done this before. You can do it by something called the sit-up test, and basically this can refer to the sit-up bleep test. I don't know if anyone's done this, it's horrific. And what happens? Continuous sit-ups at progressive intensities until exhaustion. So the beeps get closer together as you go through, and you're trying to hit the beep whilst you're doing your sit-up test. Now, advantage, it's very simple to perform. You can do it with large groups. However, there is extreme strain on the lower back. Okay, so they are your tests to evaluate strength, if you can make good notes on those. And finally, you've got factors affecting strength. Now, if I just said to you now, certain things will dictate whether you, as an individual, have strength. Okay, and I suppose the first thing we need to look at is your genetics. So genetics basically refer to your predisposition to have your innate or your natural predisposition or content of fast twitch fibers. Okay, particularly fast oxidative glycolytic, fast glycolytic 2A, 2B. These muscle fibers, the more you have of fast twitch 2A, 2B fibers, the greater your strength of contraction will be. Okay, so some people are born with a higher percentage of fast 2A, 2B fibers, therefore their contractions or their strength is higher. Next one is a cross-sectional area of the muscle. So cross-section, how big it is. Okay, so what it's saying then is some people have a larger cross section, so a bigger kind of I suppose diameter of their muscle, therefore they have a bigger motor neuron. Remember we talked about motor neuron within motor unit, and if you have a larger cross section, it just makes sense, doesn't it? The bigger your muscle, the more forceful the contractions. Okay, so remember the FOC, force of contraction, that we use for muscle fibers. Training specificity. So what this refers to then is you're more likely to have strength if your training aligns to what you're trying to do. So to example, to increase strength. And I'll look at that and think really, it's what it's saying then is if you do lots of kind of weight training, you're more likely to increase your strength. If you do lots of kind of aerobic or continuous training, you're more likely to improve your aerobic capacity. So it wouldn't improve your strength. I think that's pretty straightforward, common sense. Age then. Age is another factor affecting from the age of 20 to 30, sometimes lower, 17, 18 to 30. There will be a kind of that's your optimal age. So that is the point where you have the highest level, if you're males, of testosterone. Okay, and this then, I mean, it's quite important. To just change this bit here. There is a decrease in strength from the age of 30. That's not supposed to have 20 there, so if you could just change that. So there's a decrease in strength from the age of 30. Okay, onwards. Final one. Okay, with regard to factors affecting strength, refers to gender. So gender, if you are male, you have a higher amount of the hormone testosterone, therefore you have higher strength. Okay, so there's more chance of having higher strength. So I mean, if you have higher testosterone, it means that your cross-sectional area of your muscles bigger as well, which goes back up to here. So this will basically mean that you have a higher level of strength. So females have a higher proportion, or sorry, a higher amount of the hormone estrogen, okay, which doesn't really give much in the way of strength benefits. Okay, so that is why males would have higher strength than females. Okay, so thank you very much for that screencast. If you make good notes on that, please, that would be great. Thank you.